My name is Sid Meja from Group 5 Session 2 in Introduction of Civil Engineering. Today we like to talk about the assignment we done in this semester. Our group members are Nurul Jana binti Rahman, Azmisha bin Azlisha, Awis Kroni bin Asman, and Iftishan Ahmed FT. The title of assignment that we done are Structure of 5-story building, an issue of civil engineering related to tropical climate. We also have combined with another group that is Group 5 Session 4 in Introduction of Civil Engineering. The title of assignment that they done are Water and Engineering Consumption and Climate Change and Tsunami. Civil engineering is a diverse field that encompasses various subdisciplines, each composing of different aspects of designing, constructing, and maintaining infrastructure. Here are some key subfields of civil engineering. First is structural engineering. Structural engineering focuses on design and analysis of structures such as building, bridge, dam, and towers to ensure their safety and stability. For the geotechnical engineering, they focus on study of soil, rock, and subsurface material to assist their property and behavior in construction projects. For the transportation engineering, they focus on planning, design, and operating of transportation systems including roads, highway, railway, and airports. For the water resources engineering, they focus on management of water resources, including water supply, drainage, flood control, and irrigation. For the environmental engineering, they focus on addressing environmental issues related to construction and infrastructure projects. For the construction engineering and management, they focus on project management and supervision of construction projects from inception to completion. First, the assignment that we done are structure of 5-story building, that is FABU. FABU is the Faculty of Building Environmental and Surveying in UTM. This is the front photo for the FABU. This is the photo that we take from top, from the highest story, from the highest floor. This is the picture that we take from lower to high. This is column system of the building. This is trough roof system of the building. And also this is column design of the building. The material used in FABU is OPC, ordinary Portland cement, steel, clay type roof, and also glass. They also use wood for floor, wall, support, and also door. That's all for me. Thank you.
Hi everyone, my name is Nurul Jannah and I will explain about issues of civil engineering that are related to tropical climate. There are 3 issues that are related to tropical climate. The first one is geological engineering, the second one is geotechnical engineering, and the last one is transportation engineering. For geological engineering, they are involved with impact studies for facilities and operation that affect surface and subsurface environment. For example, rock excavation, landslide risk assessment, and slope and field stabilization. There are several problems that they are facing in doing their project. For example, high rainfall and erosion, material durability, expensive soil, and the last one is tropical cyclone and wind loads. For the second issue, which is geotechnical engineering, for your information, geotechnical engineering uses the principle of soil mechanics and rock mechanics to solve its engineering problem. The problem that are related to geotechnical engineering is high temperature and humidity, seasonal rainfall and monsoon, aggressive soil and corrosion, and the last one is high groundwater table. The last issue is transportation engineering. Transportation engineering is a branch of civil engineering that involves the planning, design, operation, and maintenance of transportation system to help build smart, safe, and livable community. This issue commonly facing problems such as heavy rainfall and flood, hot and humid climate, cyclic loading from heavy rain and drying condition, and resilience to extreme weather events.
Assalamualaikum everyone. So today I'm going to present to you guys about average water consumption and energy water consumption. Consumption in a 5 prayers, which are Subuh, Zohor, Asar, Maghrib, Isha. And with some of the people who have 20, 25, 30, 50, and 50, we get this 175 people in a day. So in the September, we have 2,800 within 16 days, and we have 3,150 within 18 days, and we have 3,150 in November within 18 days. Then data water consumption in Surah within 3 months, we have months 9 we get water consumption 14 meter cube, and we get the amount is at ringgit 10 cents, and in month 10 we get 20 meter cube for water consumption, and we have 11 ringgit 60 cents, and for month 11 we have 16 meter cube, and we get 900 ringgit 30 cents, And we all sum up of the water consumption and we get 50 ringgit, and the amount we have got 29 ringgit. So water consumption per month, we get 16.67 meter cube over a month by using the formula of total water usage over total number of months, and we get 50 meter cube over 3 months. So the water consumption per person, we have total water consumption in 3 months over total number of people, and we get 5.49 or times 10 power negative 3. There are strategies to reduce the consumption. First, we have the use automatic pipe water. Automated. Consider installing rainwater harvesting system to collect and store rainwater. For example, rainwater can be collected in a big tank or system. Third, through education to increase the awareness of water conservation. Organize a campaign or a talk regularly to teach people about the correct ways and importance to reduce water consumption. So this is the reference of Bil Ayi in Surah Al-Musawwir in 3 months. And the data energy consumptions within 3 months. The data consumptions within 3 months, we have month's line. Energy consumptions, we have 1064 kilowatt, and the amount is 594.51 cents. And month 10 we have 1258 kilowatt, and we have 701.30 cents. And for month 11 we have 1236 kilowatt, and we have 689.81 cents. When we sum up for the energy consumption, we get 3558 kilowatt and 1985.62 ringgit. So the average consumption, we get 1186 kilowatt. Energy consumption of each people in a month, we get 0.130 kilowatt. In Surah B, for the 5 prayers, in Subuh, Zuhur, Asar, Maghrib, Isha, we have 15, 20, 25, 35, and 35. And when we sum up, we have 130 people in a day. So in September, we have 3,080 ringgit within 16 days. And in October, we have 3,350 people within 80 days. And in November, we have 3,340 people in 18 days. So the total is 6,760. So we have in month 9 we get 704 kilowatt, and the amount is 375 ringgit 9 cents. And the month 10 we have 778 kilowatt with 376 ringgit 71 cents. And in the month 11 we have 672 kilowatt, and we get the amount is 357 ringgit 78 cents. But when we sum out all the energy consumption, we get 2,083, and the amount is 1,109.61 cents. So the average energy consumptions 83 months, we get 964.33 kilowatt. So the energy consumption in each people in a month, we get 0.103 kilowatt. So a way to saving the appliance by using energy saving appliance. There are energy saving appliances that are star rated by the manufacturing company, which use less energy compared to non-star rated appliance. This method can prevent the appliance from overusing the energy. Ventilate your house. By ventilating your house can keep your house cooler, which can reduce the use of air conditioners. This significantly reduces the consumption of energy. By optimizing light usage, usage contributes the most for energy consumption, as it is always switch off the lights when you are not using it and only open it when it is necessary. Replacing the traditional incandescent lights to LED or CFL bulbs can also reduce the energy consumption. Lastly, by use sunlight to your advantage. Choose window treatments that allow you to use natural light while reducing heat loss and heat. So this is the reference of Surah Al-Musawwir in Surah A. And this is in Surah B Al-Muhajirin. And that's all for me. Thank you.
Climate change is a primary caused by human activity that release the greenhouse gas into the atmosphere. Here's some of the main factors contributing to climate change. First is burning of fossil fuel, that the burning of coal, oil and natural gas for energy and transportation release carbon dioxide into the atmosphere. Next is deforestation, is the cutting down of the burning of forests, mainly in tropical region, reduce Earth's capacity to absorb carbon dioxide through the photosynthesis. Next is agriculture. Agriculture is particularly like rice cultivation and livestock farming. Particularly cattle release significant amount of methane. Industrial process. Industrial activity release various greenhouse gas, including carbon dioxide and methane. During manufacturing process, chemical production and waste management. Next is last use change. Last use change, such as urbanization and construction, can lead to the release of stored carbon in soil vegetation. Lastly is waste management. Improper disposal and decomposition of waste landfill produce the methane and carbon dioxide. Climate change has brought impact on water resource management and coastal area, and the impact is closely tied to the several sustainable development goals outlined by United Nations. First is Goal 6, which is clean water and sanitation. For example, the rise of global temperature can lead to the change in precipitation pattern and consequently affect the availability and distribution of water resources. Next is climate action. Climate change has significant impact on water resource management and coastal area, and goal 13 is the urgent action. Next is life below water. To conserve and sustainability, use ocean, sea and marine resources for sustainable development. Lastly is life of land. The objective of this goal is to restore and promote suitable use for restoration, ecosystem sustainability, management forests, combat desertification, and health.
Now I'm going to answer the bonus question that was presented to us. That is, what are the recent challenges that are faced by the civil engineers currently while working in the current climate conditions in the world? So in recent years, as we can see, the climate change has become a significant concern for civil engineers, introducing new challenges and issues in the field. One of the most primary problems faced by civil engineers due to climate change is the increased frequency and intensity of extreme weather events. Here are some of the key problems that are faced and potential solutions that we are presenting. Number one, as the global warming rate is alarmingly high currently, we can see that there is increased flooding. So the issue is the rising of sea levels, where the polar caps at the Arctic circles and the Antarctica and the North Pole and South Pole are melting, which in turn is rising the sea levels and changing the precipitation patterns, contribute to increased flooding, and in many regions posing a threat to infrastructure as well. The solution to this can be implementing resilient and sustainable designs such as elevated structures, flood barriers, and improved stormwater management systems can help in mitigating the impact of flooding. And then we have the heat stress on materials, which is the extreme temperatures can cause thermal expansion and contraction, leading to structural damages and reduced lifespan of materials of those structures like asphalt and concrete, which, as we know, for civil engineers, concrete is the bread and butter for building any sort of structures or the most general infrastructures in society. So the proposed solution, or the probable solution for this, can be research and developing climate resilient materials that can withstand temperature changes and temperature variations that are occurring currently in the world. Changing geotechnical conditions. The climate change can alter soil characteristics, affecting the stability and bearing capacity of foundations. As we know, foundations are literally the most important and detrimental thing for any infrastructure to survive in these conditions. So the solutions can be to conduct a thorough geotechnical investigation, monitor soil conditions regularly, and adapt foundation designs based on the changes of the environment that are currently ongoing. Then we have the increased risk of wildfires. Wildfires can damage transportation infrastructure, including bridges and roadways, leading to safety hazards and increased maintenance costs. Solution to this could be implementing fire-resistant materials in construction, creating defensible spaces around critical infrastructure, and employing early warning systems that can help reduce the impact of wildfires on civil engineering structures. Then we move on to sea level rise and coastal erosion. As we previously, at the start of the presentation, we have talked about the increase of sea level because of the polar caps melting, which in turn also increases the probability of having coastal erosions in the most coastal areas where structures are built. For such cases, the probable solutions can be to develop and implement coastal protection measures, such as seawalls, beach nourishments, and sustainable coastal management plans. Additionally, considering strategical relocation of vulnerable infrastructure away from high-risk areas of coastal erosion. Also, that's a given that we should also use erosion-resilient materials while building structures near coastal areas or sea areas. Then we go to resource scarcity. As we know, materials and resources are a key element to building any structure in the world, and that climate change can affect the availability of construction materials such as water, aggregates, and leading to an increased cost and logistical challenges. Solution to be promoting sustainable construction practices and including recycling and reusing of materials from older structures or usable materials, and if we also implement biodegradable materials so that the materials not increase as wastage after the structure has been destroyed or demolished. Then we can move on to our points where subsidence due to groundwater extraction. The issue is over-extraction of groundwater for various purposes can lead to subsidence, causing the ground to sink and impacting infrastructure stability. Solution to this can be implement sustainable and water management practices, promote the use of alternative water resources, and invest in technologies like subsurface monitoring to detect potential subsidence early. We go on to structural health monitoring for aging infrastructures, where the issue is many regions globally have aging infrastructures that require constant monitoring for structural health. This includes bridges, dams, and other critical structures. The solution for this can be implementing advanced structural health monitoring systems using sensors, IoT devices, and data analytics to assess the condition of aging infrastructures in real time. Then we move on to our point that we already discussed, having biodegradable materials used in infrastructures. Lastly, we move on to our last one, which is construction noise pollution. As we know, it's a given when we are building any infrastructure in the city area or even in the rural area, but mostly in the city area, the urban areas construction projects contribute to a lot of noise pollution. The solution to this can be employing noise reduction technologies and construction methods, implementing construction scheduling to minimize noise during sensitive hours, and monitoring the vibration patterns and the noise patterns for construction, and making sure that there are no hospitals or school areas or religious areas around the places where construction is being held, and monitoring properly. Finally, in conclusion, we can address challenges posed by climate change in civil engineering requires a multifaceted approach, including innovative designs, strategies, resilient materials, and sustainable construction practices. Collaboration with engineers, policymakers, and researchers is crucial to developing and implementing effective solutions to mitigate the impact of climate change on built environment. So that is the imposed question, and that is the probable solution presented by our group. Thank you very much.